Hi, I'm Skylar, a previous LA and CS33, and today we're going to do a bomb lab slash possibly midterm question, probably not midterm question, but bomb type question on the topic is strings. Okay, so first things first, I had a bunch of snippets. First thing you want to notice is this thing. Oftentimes it's really important to read these little comments here. Helps a lot. So this is like some secret. We can find it using this. We break here. The reason why I had to break here and I couldn't just inspect it is a lot of times like it's like not initialized yet. So I did that, and I wanted to see what was at this register. And the reason why is because if you notice, we have these two things, and RSI is basically the secret, and RDI is our inputs, and we're comparing it using string compare. Okay. Obviously we don't know that yet, and I'll explain why that's the case, but I'm just giving you a little bit information up front, and then I'll dive into why you can make this conclusion. And then another thing is, like, I know I did this, but on an exam, if you do get a question like this, you will not get the actual string, because that'd be that wouldn't test a lot of your knowledge, so you would probably just get hex. But as we know, C strings, the actual thing that's being stored is not P, but the hexadecimal equivalent, which is 70. Okay? And 72 is hexadecimal equivalent of R. And 65 is the hexadecimal equivalent of E. And we know that our string is done because C strings are null terminated. So we have a 0, 0 here. So this entire thing would correspond to this entire string right here. Of course, we wouldn't even have this string, right? But we would have this instead. But you can verify that this is the same as this. Okay. Okay. Another way you can verify is just like look at the pattern. So it's pretty, PRETTY, right, and then space. PRETTY, then space. Okay. Another thing is, like, if I would print out the ASCII table in my cheat sheet, but I'm pretty sure you'll be given it on the test. Okay, so that's a little context, but now let's actually dive into how I was able to make this conclusion. Okay, first of all, we see this thing. Okay, so it looks like we're going to move wherever this position is into REX. And one way to do bomb lab in these type of questions is just to do exactly what the instruction says. But another way is just to understand conceptually what is going on. So I'm going to bring a visual. If you notice from this picture, right, RBP is basically the same as this frame pointer right here. So negative 110 in hex would just be like going down like negative 110 in hex. And therefore, we're making space to like put our string like this, right? Because strings, when you place a string or place any array, right? Because a string is a character array, you start with the lower address and you go up. Okay. So yeah. Okay, so that's like a little bit of a hint on what is actually being done here. And there's also this thing right here. We're moving 100 to ESI. And I'll just tell you exactly what this does right now. This is basically initializing a character array of 256 bytes. Yeah. And then we move REX into RDI. So what that means is, back to our stack example, let's say negative 110 was right here. Say this was a 0, like relative addressing. That means REX now holds like whatever is right here, this address right here. So it's basically like a reference to our character array, right? That can like span this entire place. Okay. And now we're going to move RDX into RSI. But what is RDX? Well, RDX, as you can see from here, stores our secret, which on the test will be given like this. Okay? And we're putting that into RSI, which is the second argument, right? That's reserved for the second argument. And we're putting into RDI REX, which is in this case this whatever this C string is. Okay? And then we're calling string compare, which takes in two parameters, RSI and RDI, and compares them. Now, what does string compare actually do? Well, if it's the same, if the two strings are the same, it will return 0. Okay, if it's not, it'll return something else. I kind of forgot what that thing was. Other thing was, but I know for a fact that if it's the same, it will return 0. Okay, now that we understand that, let's look here. What does test EAX do? So test actually modifies the flags as a result, and then like the thing is say test R1, R2, it will AND them and modify the flags with that result. So if you notice, this next thing right here is a jump equal. Jump equals happens when the 0 flag is on. And if you notice from here, right, when will something like this, where you're doing the same exact thing, let's put R1 because that's the exact example. When you're ANDing anything with itself, the only time it will be 0 is if the register itself was 0. Okay? And EAX is the return register, which has the result from this. And as I said, it'll return 0 only if the two strings are the same. Which is to say, this jump will be taken if the 0 flag is on, which is only on when EAX is 0, which is only 0 when these two strings are the same, RSI from RDI. And RDI, again, is our inputs. And RSI is our secrets. Okay? So, this jump equal will take only if the two strings are the same. And it goes to right here, which is good for us because it avoids explode. But if it's not the same, it'll skip this jump. Or sorry, it won't skip it, but it won't resolve. And it'll call us moving to explode the bomb. So what this is saying is that these two strings have to be the same. Our secret and whatever our, in this case, input. And we know it's input because of this fkits. This fkits is a thing that actually populates from like down here. Say this was negative, like again, I'll keep writing it just to get it in. But say, so this fkits is the thing that actually fills up with whatever you type in. Okay? Yeah, so that means for the specific phase, we have to type in this string. I hope that helps.